To integrate this, you are going to use integration by part. The general formula for integration by part is what? uv minus integral of v du. I know you are going to ask the question, why are we going to use integration by part? When we have a function that is to integrate like a function f of x and g of x, f of x and g of x are not related, we use usually integration by part since they are not related, and we consider this as a u and this as a v. Okay, that is the usual method. Okay, you are not using the normal method of integration like integration of f of x that usually give what, like x to the like n, that is n plus 1 all over n plus 1. Usually when we have integral of that, like there is f of x equals to x to the n. To integrate this, you use this general method. There are multiple methods to integrate, but today you're going to use integration by part. Let's get to it. You're going to understand better. Okay, what are we going to consider as our u? Our u is equals to what? Our u is equals to x. Why do you consider u as x, not e to the x plus 2? Because if you differentiate u, you are going to have what? A 1 directly. Okay, but in the case if you took our u equals to what? E to the x plus 2, you find yourself differentiating this, you're going to have du is equals to what? You're going to have it's the same e to the x plus 2. And you see that this is not normal, since you're going to keep having a repetition and it's going to be in a circular manner. The main purpose here is that when you differentiate something, it should go directly to a constant. There's a part where you choose as your u. The part you choose as your u is the one, if you differentiate, it moves directly to a constant, or is moving close to a constant, as if it was like x squared. Now when you differentiate x squared, it is like x squared. If you differentiate x squared, you're going to have what? 2x. If you differentiate 2x in the second part, you're going to have what? A 2. And that is a constant. But if you have an e to the x, and you differentiate e to the x, you find yourself having e to the x to the infinity. And that is a wrong choice. But in the case, you have to choose this as your dv, so that you integrate this and come back to e to the x. Then you use this to eliminate the f of x in the equation, and you are left with a g of x at the end. Okay, I know this mathematics is a bit confusing. Let's get into it. Okay, we take our u as what? X. That is like f of x. Just consider as that. You take du is equals to what? 1. Okay, you differentiate. Therefore, we are going to take our dv, because in integration by part, we have something like what? We take one as u, and that is in this form, u dv. Okay, that is something like this, u dv. Therefore, this is u and the other one is dv. You have to choose which one is u and the other one is dv. It's not necessarily this order, but any order. You have to choose which one is u and the other one is dv. Okay, let's integrate. We have then for dv, we are going to be taking what? E to the x plus 2. Therefore, we have to find for u, that is for v, that is what? E to the x plus 2. I know you're asking the question, how can we integrate e to the x plus 2 and you have this? Okay, integrating e to the x plus 2 gx, we have to take our u is equals to what? X plus 2. After this, I'm going to give you the short formula to find directly the integral of this. Therefore, our du is equals to what? 1. Okay, therefore our integral will be what? Integral of e to the u, since this is u. Our gx is, because it's du all over gx, therefore our gx is what? Du all over 1. That will be equal to integral of e to the u, that is equals to e to the u. And you have just to substitute our u back in the equation. Our u is what? X plus 2. Hence you have x plus 2. Okay, a shortened formula, if you have integral of e to the like f of x, just consider integral of e to the f of x dx. Okay, you are asked to differentiate this. To integrate this, sorry, the integral of it will be what? E to the f of x all over f of x prime, generally, depending on the condition, that is plus a constant, don't forget. Okay, in multiple conditions, this is what happens, except when f of x, when our x is something similar, because if it's like x squared, this formula will not work. But if the x is of first degree, the formula will be obeyed. This formula only work for first degree function or first degree polynomial. You can take like that. Okay, because if you have an x square, you are going to have 2x, and you can put 2x down here. That will be contradictory, because in the numerator you are going to be having e to the u all over 2x du. How can you integrate in terms of this? In this point you are going to take, because if our u is equals to like x square, from here you can find x is what? The square root of u. Okay, therefore here you are going to have what? Square root of u, not x. Okay, and you're going to integrate this. You're going to do this in another video. Let's not make this video too long. Okay, hope you understood what happened here. This condition only work for first degree polynomial, that is first degree like x plus maybe 2 or anything like that. Okay, that is first degree. Here is 1. The power of x here is always 1. If x is 2 already, this cannot work. Take that into consideration. Okay, let's come back to our initial problem. That is a first degree polynomials, a first degree, that is first degree equation. Okay, let's consider this and solve it. You have v is equals to this. Therefore, you can then substitute this back in our initial equation. You can first of all remove this thing and put on the side, okay, and replace it with what? A and B. To avoid confusion, we replace this with A and B. Okay. Okay. Therefore, our equation is something like this with A and B. We just put like that. At the end, we are going to resubstitute it back. Okay. Let's substitute this in the equation. That is uv minus integral of v du. Okay. Substituting it back. What's our u? The equation will be what? What's a u? That is 1. That is u is okay. U is x. That is e to the x plus 2 minus integral of what? That is from 0 to 2. Let's take from a to b of what? From a to b of, that is v du. That is e to the x plus 2. That's what you are going to be having. Okay, we are going to be having still from range with a and b here. Let's just put it aside. Okay, we are going to be having what at the end? That is x e to the x plus 2. Hope you guys are understanding this question or how you are solving it. If you don't understand, drop in the comment. You are worries, we are going to do it in another video. And if you find it interesting or want to work with me, you can subscribe. Okay, we integrate this. That will be the same thing. That will be what? Minus e to the x plus 2. You have then our limit. That is our boundaries. That is 0 to 2. This is just like a curve. You can just consider it as a curve. And this is the limit from 0 to 2. And this is the shaded portion. Okay. Integral is you find the area under this curve. This is the area. You have to find this area. And if you integrate this curve with these boundaries, you are going to be finding this small area. It's actually what we usually do when you are integrating. I know you guys just cram that integration like this. No, that is what actually happened. Here we can substitute back our answer. You can, that is 2 e to the 2 plus 2, that is 4, minus e to the 4. Okay, minus for 0, that is 0. 0 times that is 0. Okay, that is e to the 0 plus that is e to the 2. Okay, you can further simplify this. That is what? Equals to e to the 4 minus that is e to the 4 minus e square. E to the 2, sorry. Okay, that will be equal e to the 4 minus e to the 2. E to the 4 can be equal to what? E to the 2 square. Okay, minus e to the 2. So you can bring down this 2, that will be 2 e to the 2 minus e to the 2. Therefore, our answer will be e to the 2. I know some of you guys are going to ask, why are we not putting a constant here? Yeah, you are right. Why are we not putting a constant while integrating this? Although usually in our school, they always tell us to put a constant while integrating. We don't put a constant because there is a boundary that is from 0 to 2. In case that was a normal integral, like x squared, at the end you are going to be having what? X cubed on 3 plus a constant k, because there is no boundaries. But when there's already a boundary, there's for a specific region, like a curve. Like you can take a curve of x or f of x that is like this. Let's just consider this. It's an infinite curve. And if you integrate this, you have to find the area that will be without boundaries. Like if you x squared like that, you can have x cubed on 3 plus k. Okay, there's a constant because there is no limitation to this curve. But as long as they have already told us that this is the limit, we are going to find the area, you consider the boundary. And we want to substitute it here and have the exact area that is in unit square. Okay, you are going to punch this on your calculator and have a specific value and approximate value. Thanks for watching this video to the end. This was the Northwest Mock 2024. That is question 7.1. We're going to solve another question in our another video. You don't want to stress up solving a lot of video at the same time. I'm going to do it gently, and you guys are going to understand very well. Goodbye.